We're starting chapter 7, and chapter 7 is about estimation. And if you recall, in chapter 4, we talked about different types of inferences. So estimation was one of these. So estimation is a type of inference, which just means you're going to take information from a sample and infer those calculations upon the population. Before we get into 7.1, we're going to look at some introductory terminology and just some things I want you to know before we jump into 7.1. So all of chapter 7 focuses on estimating a population parameter. Now the purpose of estimating a number is because you do not have it. So what we're going to be encountering is there is a population parameter or population value that we do not have, so we're going to estimate that value. Because of time and money, difficulty in finding population members, and so forth, we usually do not have access to all measurements to an entire population. Instead, we rely on the information from a sample to estimate the population parameter. So what we will eventually be doing is creating what are called confidence intervals. But before we do, we need to talk about what point estimate means. A point estimate is an estimate of a population parameter given by a single number. If we do not know the value of a population parameter, the best we can do is estimate it using the point estimate. Point estimate is also known as your best guess. We don't know the value of a population parameter, so we are going to give our best guess, or in other words, we're going to give our point estimate. The point estimate, or the best guess for mu, is x bar. The point estimate for sigma is s. The point estimate for p is p hat. So if you'll notice, mu, which is the population mean, sigma, the population standard deviation, p, the population proportion, these are all population parameters that we do not have those values, so we're going to give our best guess, which is x bar, s, and p hat. And these values all come from a sample. So what we will do is we will create an interval. So we're going to be creating what is called an interval based upon how confident we want to be that the interval actually includes the value of the population mean. And then we're going to look at, do we want to be 90% confident, 95% confident, or 99% confident? So what we can look at is, in a normal distribution, we know that this is mu, but we don't know what mu is. So what we're going to talk about when it says 90% confident, that would be if this were 90%, (95%) would be the same, except you're just going to go a little bit further out. So 95% means that this, from this number to this number, is wider than it would have been in the 90%. Because to get 95% of the curve, you have to go out wider. And the same would then hold true then if you were looking at the 99%. It would even go out further. Whoops. These are just kind of rough drafts. So you have 90%, a little wider is 95%, and then a little wider is 99%. Now, on these confidence intervals, it says for each confidence interval, the reliability of our estimate will be measured by the confidence level. And this is called C. Now, C will always be given. It will tell you how confident it wants you to be. For a confidence level, the critical value Z sub C is the number such the area under the normal curve is between negative Z sub C and Z sub C, and so forth. So that's kind of just getting you familiar with confidence intervals. Now, when estimating, so again, we have a population parameter that is unknown, so we are going to estimate it, which means the likelihood that we calculate the exact number is probably not very high because we're just estimating. We must also consider what is called the margin of error. The margin of error is the magnitude of the difference between the sample point estimate and the true population parameter value, x bar minus mu, so whatever this difference is. Now, here's an example of what I'm kind of talking about as far as margin of error and creating an interval. So let's think back to our last presidential election. And I'm just going to talk about the state of Oklahoma. So before the election had actually happened, obviously we know that it was Trump versus Clinton. So before the voting actually happened, sometimes if you watched the news, it would come on, and I'm making these numbers up. I have no idea what they were at the time. But in the state of Oklahoma, the news might say, right now, Oklahoma, Trump is winning 52% to 48%. Now, how do they get this number? Because obviously, the election has not happened. They're not going to go and ask everybody. So at the bottom, a lot of times, what you'll see is something like 1,000 registered voters, and then it'll say plus or minus 3%. So what they did was they did not know the population. They did not know the population parameter to how Oklahoma would vote. So they asked 1,000 registered voters, and they inferred these numbers upon the whole state. This number right here is what is called the margin of error, because they are saying we believe Trump is going to win 52%, but that is within a margin of error of plus or minus 3%, which means we're fairly confident he's going to get anywhere from 49 to 55%. So all I did is took 52 minus 3 and then 52 plus 3. And then for Clinton, it's saying we believe her that she is going to get 48% of the vote, but based upon our margin of error, it could be anywhere from 45% to 51%. And these are what we would call our intervals. So intervals will always include two numbers, a lower value or an upper value. Okay, so that's kind of an introduction. So now we're going to get into 7.1. And what we will be estimating is mu. So the population mean is unknown. Population mean is unknown. Now, in 7.1, they're telling us that sigma, or the population standard deviation, is known. So the mean is not, but the standard deviation is. So in this section, we're going to estimate mu. We will start with our point estimate, or our best guess, which the point estimate for mu is always x bar. We will create an interval around x bar to estimate the population mean mu. And then we will make our interval based upon how confident we want to be. Now, the most typical confidence levels that we use are 90%, 95%, and 99%. And this gives us our Z values for that. Now, I've included these in the notes, but if you'll go to your Z table on the positive side, so this is the Z table we've been using. In the lower left corner is the confidence interval critical value Z sub C. Now, I've given you 90, 95, and 99, but you'll notice there are other percentages as well. So you might be asked some of these, so be sure you know where to get those, and those are on the lower left corner of the positive Z tables chart that we've been using. All right, so the first thing that we need to know is how do we calculate the margin of error? So again, here's how to calculate the margin of error, and this is when sigma is known. And this is that formula. So the margin of error equals Z sub C. This value comes from the table. So it will be one of these numbers, times sigma, which will be given, divided by the square root of n, which will be given within the problem as well. Once we calculate the margin of error, then we create what is called the confidence interval, and that is created by x bar minus the margin of error, x bar plus the margin of error. So this is our interval, and we're saying the population mean, which we do not know what it is, and we are estimating it. We are saying the population mean is between these two values. So let's just take a look at some examples just to get familiar with how to calculate the margin of error and the confidence interval. So we are given that x bar, the sample mean, is 83. It's telling us to be 90% confident. The population standard deviation is given as 8, and n is 35. So first is asked is, what is the point estimate for mu? Well, the point estimate for mu is always x bar. And in this problem, they told us that x bar was 83. So my best guess for the population mean is 83. The margin of error then is calculated by using that formula up above. And before I get there, I need to know, let's see, my C is 90%. So I want to know what Z sub C is. So we go to the table. 90%, it's 1.645. So to calculate the margin of error, it is 1.645 times sigma, which is 8, divided by the square root of n, which is 35. Now, to put this into your calculator, it's 1.645. Let me move that down so you can see it. Times 8 divided by the square root of 35. Come out from under my radical and push enter. So normal rounding rules, 2 decimal places, 2.22. Again, on WebAssign, pay attention to the directions, because if it says round to 3 decimal places, if you just round to 2, it will count it incorrect. So be sure you pay close attention to that. But for notes, I'm going to round to 2 decimal places. So that is my margin of error. And now we're going to create the confidence interval. The confidence interval is x bar, which was given, minus the margin of error that we just calculated, and we are estimating mu, and then x bar plus the margin of error. So then I calculate that, and I get 80.78 and 85.22. So in this example, here's what we're saying. We do not know mu. We do not know the population mean mu. But my best guess for mu is that it's 83. But if it's not 83, I'm 90% confident it is a number between these two values. Next example. The president of a large university wishes to estimate the average age of the students presently enrolled. From past studies, sigma is known to be 2 years. A sample of 50 students, So n equals 50 is selected, and the mean is found to be 23.2 years. So this mean right here of 23.2 is referring back to the sample of 50. So that is x bar equals 23.2. Find the 95% confidence interval. So C is equal to 95%. So I know Z sub C, I go to the table to look. 95% is 1.96. So the first thing that we're going to do is calculate the margin of error. And that is E equals Z sub C, 1.96, times sigma 2 divided by the square root of n, 50. And when you calculate that to 2 decimal places, normal rounding rules, you get 0.55. The second thing that we're going to do is create our confidence interval. And our confidence interval is x bar, which was given to be 23.2 minus my margin of error, and 23.2 plus my margin of error. So we get 22.65 and 23.75. Now, if you were asked to explain this in sentence form, what this interval means, it could be stated as I am 95% confident the average age of students presently enrolled is 22.65 to 23.75 years old. So, main things that you need to be sure that you understand on this is your point estimate values or terminology, and then remember that this is the formula that you use. This is the formula you use when sigma is known, and then this is your confidence interval.